Okay, good day, guys. This is an acid-base reactions. We call it its neutralization reaction. This is a revision in grade 11, but the acids they start from earlier grades. Now let's start by defining what is an acid. There are two ways of defining an acid. There's an Arrhenius definition and there's a Lowry and Bronsted definition. There are two definitions. Let's look at the first one. In the first one, according to Arrhenius, it says an acid is a substance that produces a hydrogen ion or oxonium ion when dissolved in water. So any substance that we dissolve in water and it produces the hydrogen ion or the oxonium ion, we call that it's an acid. Now, the definition according to Lowry Bronsted, acid is a proton donor. So an acid, it donates proton, right? Let's look at the example of an acid. When you dissolve it in water, it's going to produce the hydrogen ion or an oxonium. Let's take one of the common acid, hydrogen chloride. We dissolve it in water. So when we dissolve it in water, what's going to happen? An acid, it's going to donate its proton there, carried by hydrogen. So the water here, it's going to accept that, and then it's going to give us the H3. Now in this water, it has taken the hydrogen ion, so there will be 3 hydrogen with an oxygen and the net charge there. Now what's going to remain here, it's going to be Cl minus, which is it's a chloride ion. So looking at this acid was dissolved in water. Now it produced this oxonium ion, or it's a hydronium ion, right? Let's look at an example. Let's take another acid. Let's do the same way, but now the water, we put it there. Now we are dissolving water here as well, but what's going to happen, this acid is going to ionize. There will be an H plus ionizing. That means it's going to split into ions. There will be an H plus and the Cl minus. So these are the same thing, guys. These are the same thing. This is an hydrogen ion. This is an hydronium ion. So it's the same thing. It's just that the difference between the two, the H plus is equal to the hydronium ion, but this one, it's a hydrated one. That means it's in the presence of water. They are the same thing, right? Now let's look at another example. When we take another acid, let's take an acid, nitric acid, and we dissolve it in water. So when we dissolve in water this nitric acid, what's going to happen? It's going to form the hydronium ion. Basically what happened, this hydrogen ion will go there, in water there. And there will be 3 hydrogen with an oxygen and the plus there. So what's going to remain there? It's going to be a nitrate ion. Alternatively, you can ionize this acid this way, putting the water there, and it will be what's going to happen, it's going to ionize, it will split into ions. There will be an H plus and an NO3 minus. So basically this reaction and this reaction is the same. So it's an acid that is dissolved in water. Let's say this is example 1, example 2. No. Example 2. Let's take the last acid. Let's take the one that donates 2 protons. Let's take a diprotic one, a sulfuric acid. When I add a sulfuric acid in water, it's going to ionize, but it can ionize in stages or it can just ionize once. Now, what's going to happen? A proton is going to be donated in that water. So what's going to be left there? It's going to be H, SO4 minus. There's going to be a minus there once an acid donates its proton there. Remember, there are 2 protons here. We call this one, it's diprotic acid. That means it can donate 2 protons. These one, it's monoprotic acid. These ones are monoprotic acid. They can donate 1 proton. But this one, sulfuric acid, can donate 2. So now it already donated 1 and it's left with 1. So there should be a minus there. What's going to be formed there? When that water accepts that proton, it's going to be H3O plus there. Now, that's the first ionization. We call this one is the first ionization. And the second ionization there, it's when this conjugate, will take will release another. So we'll take this, releasing the second a proton in water. So what's going to happen here? Second proton will be donated to water, and what's going to happen? It's going to form hydronium ion plus the what? The SO4 2 minus. Because now you must remember, you must put the 2 minus there. There are 2 protons that it has donated. Here it was a 1 minus because it donated 1 proton there. Alternatively, you can show this without doing it in steps. You can simply say the sulfuric acid, it's donating both its protons. So what's going to happen when it donates the 2 protons? Let's put it this way: when it donates the 2 protons, 2 protons in water, what's going to happen? What are you going to remain with here? It's going to be SO4 2 minus. Basically, it's that, and then this water will take the 2 protons. It will continue to be that, but there will be 2 of them. So it must be 2 water molecules that takes 2 protons. 1 water molecule can take 1 proton. So there must be 2 of them that takes the 2 protons. Right? Now let's look at the types of acid. Okay. Let me put it straight. When you add an acid in water, we call that as an ionization reaction. It's an ionization reaction. New ions are formed. If you look here, there are new ions formed in the product. You know? There are no ions in the reactants. New ions are formed there. So we call that it's an ionization reaction. Whenever we dissolve acid in water, as an ionization reaction. Right? Now let's look at the types of acid. As I've mentioned earlier, there are acids who donate 1 and there are acids who donate 2. Now there are monoprotic acids. The monoprotic acids are those acids who are donating 1 proton, like the HCl, the nitric acid, and and so forth and so forth. Now there's HBr as well, and the other acid. Those acids that have 1 hydrogen there, they are called monoprotic. And there are acids who are diprotic acids. The diprotic acids are acids who are donating 2 protons, like the sulfuric acid, sulfuric acid, and we have acids who are triprotic. Sorry for that. Triprotic acids. Triprotic acid is the phosphoric acid, H3PO4. H3PO4. That's the acid that is triprotic. Let me show you the triprotic acid, how it can donate. Its acid. So what's going to happen? Let's look at the phosphoric acid. When you dissolve it in water, what's going to happen there? It's going to donate its proton there, 1 proton. There will be 3 ionization. This will be the first ionization. So it's going to be H2PO4. Once it donated 1 proton there, the remainder, it will be 2 protons and the minus because it has donated 1. And then you have the hydronium ion, which is the oxonium. And also, the second ionization there, it's going to take place. You take the 2 protons that are remaining there, and you donate 1 again. So when you donate 1 proton again there, you'll be left with 1 proton, SO4 2 minus. Right? The water will take that proton. Then the third ionization, you take that single proton that is remaining there, you donate it as well in water by dissolving it in water. There's the proton that is donated there, so it's going to be SO4 3 minus, because there are 3 protons that you donated already. So it's going to be H3O plus. All right, let's talk about the base now. What is a base? We have two ways to define it. We have to define it according to Arrhenius, and we also have to define it according to Lowry and Bronsted, just like an acid. Now, according to Arrhenius, a base is a substance that produces the hydroxide ion when dissolved in water. When you dissolve an acid, a base, sorry, in water, it will produces the what? The hydroxide ion. The hydroxide ion is OH minus. That's that. So whenever you react any substance in water and it produces the hydroxide ion, that's a base. Now, according to Lowry Bronsted definition, a base is a proton acceptor. Remember, according to Lowry Bronsted, an acid, as we spoke about it before, it was a proton donor, but a base is a proton acceptor, and you must distinguish the two. According to Arrhenius, an acid was a substance that produces the hydrogen ion when dissolved in water, but the base is an acid that produces the hydroxide ion when dissolved in water. I hope you can differentiate the two. Let's look at an example. Let's say we have a base, NH3, and this base, we dissolve it in water, right? And when we dissolve this water, this base, its name, it's ammonia. Ammonia is one of the bases that ionizes. It's because all the bases, they dissociate. They dissociate all the base, but this base, it doesn't dissociate. It ionizes when dissolving in water. Now, what's going to happen? We said the base, according to Lowry and Bronsted, is a proton acceptor. So that means it must take the proton. Where it's going to get the proton? From water, right? So there's the proton from water. So now this ammonia, now it's going to turn into NH4. There's a fourth hydrogen there. There's a fourth hydrogen, and we must put the net charge there. We now call it's ammonium ion, right? What's going to happen in this water after it has donated its proton? It's going to be OH minus. Now, according to Arrhenius, we said a substance that we dissolve it in water and it forms the OH is a what? Is a base. So this qualifies this ammonia as a base. And according to Arrhenius, according to Lowry and Bronsted definition, it says a substance that donates proton, that accepts proton, is a base. The ammonia, we have witnessed that the ammonia has accepted the proton. Now, because it was NH3, now it's NH4 plus. That means it accepted the proton. Let's look at this base again, the ammonia. Now, it reacts with an acid. So when it reacts with an acid, it qualifies to be a base because it can accept. This one, it qualifies to be an acid because it has a property to donate. Now, the acid will donate a proton to a base, and the base will accept that proton. So what's going to happen there? The ammonia, it's going to turn to ammonium, right? It's going to turn into an ammonium, and this acid, it's going to turn into a what? A Cl minus. All right, you can also look at it that way. Let's look at another example of bases. The base that dissociate to an OH minus. Let's take the base of the sodium hydroxide. This is a base. The sodium hydroxide is a base, and we dissolve it in water. So what's going to happen here? This acid, what is going to do in this base? It's going to dissociate it. It's going to split it into ions. So what's going to be formed there? It's going to be NH, NH plus, and there will be what? An OH minus, right? So this base, you dissolved in water and it formed the OH minus. You can also put it in this way and say OH, you dissolve it in water like that. It's going to produce the sodium ion and the hydroxide ion. So the base that formed the OH, and we're going to even take the caustic potash. The caustic potash, when you dissolve it in water, the potassium hydroxide, it's going to be Ka plus OH. So this acid has been dissolved by water, it's dissociated by water, it formed the OH minus. Let's take another different type of base. The different type of base now that we're going to look at, let's take this hydrogen phosphate ion. Now the hydrogen phosphate ion, when you add an acid, when you add a proton into it, it's going to be, in other words, this guys qualifies to be a base at this point, because it can take it as a space, two spaces to take the proton. Remember, this comes from an acid, which is, it's a phosphoric acid, which is the phosphoric acid. Now it's full of 3 protons. Now it cannot take in this state, it cannot accept the proton in this state. Now once it lost 2, or it donated 2 proton, it has a space to take a proton. So now this is taking, this phosphate ion is taking a proton now. So this proton is going to be taken by that base, and what's going to happen, it's going to become H2PO4 minus. I hope you get that, guys. This qualifies to be a base. And alternatively, we can say HPO4 2 minus, we added it in water, and what's going to happen there? What's going to happen? Again, this acts as a base, it can accept a proton. So this water here, it will act as an acid, it's going to donate a proton in this base. So this is going to turn into H2PO4 minus in this point, because it needs 1 more proton to be stable there. So what is this water is going to turn to? Is going to turn into the OH minus, right? So this base, once it accepted the proton of water, the water turned into what? An OH minus, right? Let's look at another example, guys. Let's take the carbonate ion. The carbonate ion, when you add a proton into it, that means it will be a base. It has 2 spaces. Remember, guys, that this comes from a carbonic acid. The carbonic acid is like that. It's one of the weak acids, the carbonic acid. It's one of the diprotic acid. But now it no longer has those 2 proton. It has donated those 2 proton. Now it's going to become CO3 2 minus. Right? So let's look at this carbonic acid. This carbonic ion, it has 2 spaces for proton. Now it's taking 1 proton, so it's going to become HCO3 1 minus, because it has accepted 1 proton, and now it's in need, or it has 1 space for more proton. Alternatively, this carbonate ion, we can dissolve it in water. Once we dissolve it in water, it's going to act as a base as well. It's a base, and this water, it's going to act as as an acid. It's going to donate a proton there. So once it donates a proton there, this carbonate ion is going to become HCO3 minus, and then what is this water is going to turn into? It's going to turn into OH minus once it donated 1 proton there. As I hope you get the difference between the acids and the base by definition of Arrhenius and Lowry and Bronston. Conjugate acids and bases. Now, whenever an acid reacts with a base, they form conjugated pairs. What do we mean by that? Let's take an example. Let's say we have a base, ammonia, react with an acid. Now, what's going to happen here? This acid will donate a proton to this base, and the base will accept that proton. So when an acid donated a proton, the NH3, which is an ammonia, will become NH4 plus. Now let's look at the acid. What is going to turn into that when it donated the proton? It's going to become Cl minus, right? Now, what I want you to know today, when this base, okay, let's look at the acid first. When this acid donated a proton, what remained there is the Cl minus. So if you're looking at the difference between this HCl and the Cl minus, it's the what? It's the H plus. This one, it has the proton, and this one doesn't have a proton. So now these become pairs because the difference between them, it's the H plus. The difference between them is the H plus. They become a pair. We call them conjugated acid base pair. They become a pair because the difference between them is the H plus. Now let's look at the ammonia now. When an ammonia accepted a proton, it becomes an ammonium, right? And the difference between them again is the what? It's the H plus. If you look at the ammonia, it has three hydrogens. There are four hydrogens there. It has accepted one, and then they become four. So the difference between them, as I've mentioned, it's NH. It's H plus, which is the proton. So also we call them conjugated acid base pair, right? They pair together because they differ by a hydrogen ion there. Now let's emphasize this. When an acid donates a proton, it turns into okay, let's put it this way. When this acid donated a proton, what remained there? It's a what? It's a Cl minus. So that Cl minus, we now call it's a conjugated. We call it's a conjugated what? Base. Why do we call it's a conjugated base? Now it's because it can now accept a what? A proton. So if this ammonia, remember guys, these are reversible reactions. So if this ammonia can donate a proton into it, it will be able to accept it, right? So now that's why we call it's a conjugated base. An acid forms a conjugated what? Base after it has donated its proton. Now let's look at the ammonia. The ammonia, after it has accepted a proton, it becomes a what? It becomes an ammonium ion. So this ammonium now, it acts as a base. It can become a base, as I've mentioned, that it can donate a proton there. It has no space for another proton. So we call this one is a what? It's a conjugated what? Acid. Because it has a capability now to donate a proton because it has received a proton. These reactions, guys, are reversible reaction. So when this ammonium donates a proton in that Cl minus, it will become what it was before, which is the NH3, and the Cl minus will become an HCl there. So let's emphasize this. Let me use when base forms a conjugated acid. You see this base, it has formed a what? A conjugated acid. The acid, it has formed a conjugated base all the time when it comes to conjugate. Let's take another example. Let's say we have PO4 minus, we dissolve it in water and then produces let's say this is an acid because that's an ampholite. Let's say now it's an acid. This is a base. So what's going to happen? This is going to donate a proton here, this acid. So what's going to happen? The acid, it's going to become HPO4 2 minus, and the water that accepted the proton will be a hydronium ion. So this acid, it's after it has donated a proton, it forms a conjugated base. All the time in acid, it forms a conjugated base because the difference between them, it's what? It's H plus, the difference between them. So these are conjugate acid base pair. Now if you look at the water, after it has accepted a proton, it forms what? A conjugated one. Since this is a base, it will form a conjugated acid because now it has a capability to donate to this an H plus, and after this it has received that, it will become that. So these are pairs, the conjugated base pair. I hope you get the conjugated base pair. Now if I can ask you what is a conjugated base conjugated base of this, it will be this, right? What is a conjugated acid of water? It will be this, right? Okay. I hope you get that. Let's look at the ampholytes. A substance is amphiprotic, or is an ampholite if the substance can act both as a base or an acid. So if a substance acts as a base or it acts as an acid, we call it's an ampholite. So in other words, it has dual characteristics. It acts as a base, it acts as an acid. It depends on what it reacts with. Now let's take an example of water. Water is one of the good example of the some substances that are amphiprotic. So let's say water, when we dissolve water in water, so what's going to happen? Here it acts as an acid, so we're going to have H plus OH minus. So what basically is happening here, this water, it acts as an acid, which is it donates a proton. Here's the proton that it donates, and then it forms an OH there. Now let's look at when it acts as a base. Let's look at when it acts as a base. So if it acts as a base, that means a proton is going to accept it. Now it's accepting a proton. Here it was donating a proton. Here is accepting a proton. This proton is going to get in there. So it's going to be hydronium ion that is formed there. So this water, it acts as a base. So water, it has dual nature, which means it can act as a base and it can act as an acid. Right? Now let's look at the auto-ionization of water. Water undergo what we call auto-ionization. So the water ionizes itself automatically. Let's say if we have water reacts with what? With water, right? So one of the substances is a base, one of the substances is an acid. So let's say the first one is an acid and this one is a base. So if this one is an acid, it's going to donate a proton there, and this one, if it's a base, it's going to accept the proton there. So this is what is going to, when this one donated a proton, it's going to be OH minus. What is going to remain there? Plus. And then when this one receives and accepts the proton, it's going to be a hydronium ion. Now, if you still remember the conjugates, this is an acid. It forms what? A conjugate base. This is going to be a conjugate base. And this is a base. It forms what? A conjugate acid. Guys, there are more ampholytes. More ampholytes, we can say more ampholytes. Once a substance can act as a base and as an acid, we call it an ampholite. Let's look at HCO3 minus. This HCO3 minus, it can donate this proton that it has, or it can accept another proton there because it has a space for one and it has one proton that it can donate still. Let's look at another one. Let's look at HSO4 minus. We know that where it comes from the sulfuric acid. This one, it comes from the carbonic acid. Again, this one, it has a space to take more proton, or it can donate this proton that it has, so it acts as an ampholite. Let's look at H2PO4 minus. So we know this comes from the phosphoric acid, which phosphoric acid, it originally has 3 protons, but now this one has 2. So that means it can take a proton or it can donate protons still. And we have another one, which is, it's going to be HPO4 2 minus. So there's a proton that it can donate and there's a space for 2 protons. So these substances are ampholytes.